10.5 notes are all about tangents. So the first thing to know is what a tangent line is. So a tangent is a line in the same plane as a circle that intersects the circle in exactly one point. So if you look over here at this picture, line AB is the tangent line and it's intersecting at point A, which is called your point of tangency. So where that line touches the circle on that one point is your point of tangency. A common tangent is when you have a line or a ray or a segment that is tangent to two circles in the same plane. So if you look at these two pictures here, you can see that line L is a common tangent. It's touching at circle F and circle G in a point. And even though sometimes the circles can be intersecting and sometimes they're not intersecting, but they still have common tangents. So in example 1, we're going to identify common tangents and we're going to be drawing these in. And you want to make sure that you have a ruler for this because it's just easier. So make sure you get a ruler. I'm going to just use my lines up here. So we're looking for common tangents. So that means we're looking for, is there a line that will touch both circles in the same spot? And so if you take your ruler and you can just see, you can get a line to touch each circle in one spot, which obviously that's a terrible drawing here, so I'm going to fix mine. So if you have a ruler, it's a little bit easier to draw your line. That way you're not intersecting the circle in what looks like more than one spot. And again, you're just, kind of doing the best that you can. Okay, so that would be one. And then another one could be going the other way here, like this maybe, and I'll fix that so that it's touching. So you want to make sure when you're doing this that it looks like you're touching your circles in one spot. So if you grab your ruler, just see a little tiny bit of each circle at the same time with your ruler. That's where you're going to draw your line. Okay, so on this one, I could draw a line here where it's going to touch both. Again, it's not intersecting, so if I had a ruler, this would be a little bit easier, but I don't, so I just kind of have to make do here. Again, it's not intersecting the circle, it's just touching it in one spot each. The same thing on this side. So I'm going to draw the tangent here now. And I need to get it so it's touching both. And this one's a little going in a little bit, but you get the gist. And then also, I could draw a line. So now if you take your ruler and go more on the inside of your circles. So let me try a different color here. That might be, yep, that's pretty good. And then we'll go again in the other direction. Just try to touch it in one spot. And there's my next one. So that one has 4 common tangents. And again, you're just looking to see where can you draw lines where it's going to touch both circles in the same spot. Okay, so for this one, obviously where those circles intersect, one line will go through there. And then also, just like you did on A, I can get one, not a great picture, let me fix that, to touch here. That would be a common tangent, touching both. And then another one on the other side. That's pretty good. So again, if you're using a ruler, if you just move your ruler up, like what I would do is I would take my ruler and I would put it like this, kind of, where I could just see a tiny bit of the circle here and here, and where I can see that tiny bit of the circle, then I'm going to draw my line so that it's touching it in both spots. And then the last one, so if your lines are, or if you have concentric circles, which I guess those aren't concentric, they're just one circle inside another, but they're intersecting down here at a point. Where that intersection point is where my common tangent would be. My line of where the 2 circles meet is where my common tangent is, where that line is going to touch both circles at the same time. Okay, so that's an example of common tangents. Now, let's see what's true about a tangent. So if a line is tangent to a circle, then where it touches the circle, it is going to be perpendicular to the radius. So on this picture right here, line L is tangent to circle S, so that means it's going to form a right angle with the radius. So this is going to play an important part as we move forward in examples. So this says determine whether GH is tangent to circle F. So if this is a tangent, then that means at point G, that has to be a right angle because FG is a radius. So to determine that, I need to know, is that a right triangle? And so recall, the way we know if it's a right triangle or not is we see if those sides satisfy the Pythagorean theorem. And so I'm going to just write it like that with a question mark. So 36 plus 64 has to be equal to 144, and those actually equal 100, which is not equal. So the question is that a tangent? And the answer is no. Angle G is not a right angle because sides don't form a right triangle. So you want to keep Pythagorean theorem in your toolbox. You're going to use it a lot. If you're trying to decide if something is tangent, you're going to use the Pythagorean theorem a lot. Okay, so on 3a, we're going to find the value of x, assume that segments that appear to be tangent are. So in this case, it looks like BC is tangent because it's hitting the circle right here, which means if it is tangent, AC is a radius, so I need to have a right angle right there. So to be able to find x, again, I'm going to do the Pythagorean theorem. So x squared plus 14 squared equals 17 squared. And when I solve that for x, so if you guys plug that into your calculators and solve, you would get the square root of 93, or as a decimal, 9.64 would be my answer. Okay, then on this one, again, QS would be my tangent line because it's touching the circle in one spot. So angle Q would form a right angle with this radius. Now, that side isn't labeled. However, remember that in a circle, all radii are the same length. So if you notice, this radius right here is x. That means this radius has to be x. When I do the Pythagorean theorem, I have to use all three sides of my triangle. So this side length, I need to write it as a whole side would actually be x plus 2. So when I do this problem, I'm going to do 4 squared plus x squared is equal to that entire side. That's the quantity squared. You have to make sure that whole side gets in parentheses. So now I have 16 plus x squared. And then remember to do this. This is doing x plus 2 times x plus 2. So you're going to FOIL this. Okay, so I would get x squared plus, so when I multiply my outside, x times 2 is 2x. My inside, 2 times x is 2x. Add them together, that's 4x. And then plus my last, 2 times 2 is 4. Okay, and now I'm going to solve. So I'm going to get my x squareds on the same side. So to move my x squared over, I'm going to subtract it. And you should notice what happens. Now your x squareds are going to cancel out. So 16 equals 4x plus 4. And then I'm going to subtract 4. And I'm going to divide by 4. So x will equal 3 on that example. All right, now the next one. If you have two segments that are coming from the same exterior point, so now we have a tangent line here, and we have a tangent line here, and they're both coming from this common point B outside the circle. If that happens, then the conclusion is that BC and BA are going to be congruent to each other. So again, that's more information to memorize. You need to memorize tangents are perpendicular, but you also need to memorize if tangents come outside the circle from the same point, they're congruent. So on this one, find the value of x, assume that segments that appear to be tangent are tangent. So again, I have two tangent lines, both coming from point R. That means those are going to be congruent, so I'm going to set them equal to each other. So 3x plus 8 equals 26. I'm going to subtract 8 on both sides. 3x equals 18. Divide by 3. X equals 6. Okay, on this one, again, they are tangent lines, both coming from x outside the circle. So that means those are equal. So I'm going to set them equal. 2x plus 9 equals 3x plus 6. I'm going to subtract 2x, so that gives me 1x. And I'm going to subtract 6, which gives me 3. So x equals 3. Now, at the bottom of your notes, this is an example where it's showing you pictures where a polygon would be circumscribed about a circle. And it's only circumscribed if every side of the polygon is tangent to the circle. So if you look at these pictures, notice every side in this box here is going to be tangent to the circle. So here's something I want to point out to you. If I have a polygon circumscribed about a circle, that's a terrible drawing, but you understand. Here's something you need to pay attention to for any time you're working on a problem is this. This would be a tangent line, and this would be a tangent line. And notice they're both coming from this point here. So that means those two sides are going to be congruent. And then the same down here. And then the same here. That is important. So the concept we just talked about still applies when you have a polygon circumscribed about a circle. So on this hexagon, like those two tiny little sides would be congruent, and these two, and so on, all the way around. So that's going to be what we use to solve this last example. It says quadrilateral RSTU is circumscribed about circle J. So that means those are all tangent lines. If the perimeter is 18 units, find X. Okay, so that means AT and TB are tangent lines, both coming from T. They're congruent. That makes that side X. Same over here, BU and UC, they're congruent. Makes that X. And so on, DR and RC would make that 3. SA and SD would make that 3. So if the perimeter is 18, I can add up all the sides. So 3 plus 3 plus 3 plus 3 is 12. Plus x plus x plus x plus x is 4x. And that's going to equal 18. I'm going to subtract 12. So 4x equals 6. Divide by 4. X equals 6 over 4. But if I reduce that, that's 3 over 2. Or if you want to write it as 1.5. And there's your x. Here's your assignment for 10.5. You're going to do 10 through 26 evens and then 30 through 35. And you can begin working on that.